Okay guys, let's program op2 of this pedal arm with me. Again, I can't share the model, but follow along. I hope you get something out of it. So we have this thing in soft jaws, so we've got to cut the soft jaws first. So I'm going to go ahead and hide the pedal body. I'm going to create a virtual corner on this, similar to what we did with your 1, 2, 3 block. So I'm going to create a sketch. And I'm going to project that line and that line. Finish the sketch. Now let's go to our manufacturing forum. So let's open up these bodies here. And turn them both on. New setup. For the stock, I'm going to choose this body that I've imported from SolidWorks. It's a milling operation. I'm going to choose the Z-axis plane and X-axis. The Z is going to be the top of the part, and the X is any one of these X lines that's going in the correct direction. Now, as far as where I'm going to put the work coordinate system, I'm going to use that virtual corner on the soft jaw that I created. And then I'm going to hide the stock and choose the pedal arm as my model. Okay, what you guys might notice here is there's some extra cutouts. The reason for that is I'm reusing a soft jaw that was already cut out for something else. No big deal, we'll just kind of cut over it. So let's hide this body. What you can see is we've got our coordinate system. Actually, we've got our coordinate system in the wrong spot, so let's fix that. I projected it in the wrong spot. So let's go back to our design and let's go into our sketches. And edit sketch. No, I'm just going to do something else here, guys. I'm just going to create a new sketch. On that virtual corner here. I needed it to be on the top. So let's go back and fix our setup. So the only thing that changes with our setup is where we've chosen our coordinate system. It's on now that upper sketch in the virtual corner, not the bottom one. Okay, so now, just for ease, I'm going to turn the sketches off. I don't need them at this point. So what I'm going to do here is I'm going to cut these jaws out in the shape of the pedal arm so I can hold it. I'm going to use a 2D contour. I'm going to go with tool number 3, my 1/2-inch end mill. And I'm going to select those edges as my edges. As far as the stock goes, I'm going to select these edges. I don't like what that's doing there, so I'm going to come around to here. Now I've got the whole jaw selected as my stock, or the whole cutout as my stock. I can use the selected contours as the Z bottom. And I'm going to do a roughing pass. 2 roughing passes. And let's make our step over 0.3. And that should cover it. So that should get this jaw cut out. I do need to cut out this right here because I'm going to run a reamer through the hole, and I want to make sure that that reamer doesn't hit bottom. So I'm going to simply make another contour right here, same 1/2 inch tool. And I don't like that because it's going to plunge into my stock. So let's do this. Let's give it a little extra. It might cut into the other side a little bit. That's fine. It's just a fixture. Okay. So now let's start programming the part. Let's turn the body back on. It's making a 3D adaptive clearing. Tool number 3 is fine. I'm going to speed this thing rapidly up. 225 inches a minute. Lead in, lead out 500. Make our ramp 125. I'm not going to choose anything for the geometry. And instead of model bottom, because I don't want to cut to the model bottom, down here, I'm going to make this selection right here. And then I'm just going to hit, well, actually no. I'm going to make our maximum roughing step down 1/2 inch so that we don't have to take it in 2 passes. You guys can see that the stock to leave is 0.2 radially and 0.02 axially, 0.02 radially. So while that's generating, let's make a contour along that edge. Stock contours. Is fine. Fine. Roughing passes. 0.3. Let's go 3. And our feed rate's too high on this. So let's go back to 100 inches a minute. And let's see what we get. Okay. It's taking a little longer than expected. There we go. So now we've got to cut the O-ring groove. Again, that's a 1/8 inch end mill. It's a contour. I'm going to select. Now guys, I'm going to cheat a little bit because I just programmed the other side of this. So I've got my tools all set on the other side. So 1/8 inch end mill, 10,000 RPM, 35 inches a minute. You can't go too fast on an 1/8 inch. Select the bottom contour. This groove is 1/8 inch, so we're going to be basically finishing it all in one shot. But we want to select our top contour as that so that we don't start our ramping way up here. So let's go to ramp. 2 degrees is fine, but we need to take the lead out. Very similar to what we did before. Okay. So we've got it roughed. We've got that floor and that wall finished, and we've got our O-ring groove finished. So now let's go ahead and face this thing off. Choose face. I'm going to go with my 3-inch face mill. For me, that's tool 24. 6,000 RPM, 90 inches a minute is fine. You can leave that alone. Let's choose the selection. Let's go over here to climb cut and extend before retract. Okay. So now, this bore and this bore are precision bores that I'm going to ream. So I'm going to use a drilling operation because a ream is a drilling operation. Okay, I'm going to select a new tool. Tool number 18. We're going to go down here and select a reamer. Diameter is 0.7505. Feeds and speeds, 1,000 RPM for the reamer. That's 10,000. And 25 inches a minute. Okay. So go ahead and select OK. We're going to select that as our hole. We're going to go down 0.1 past the hole and go ahead and hit OK. We've got to do the same thing with our hole here. It's a precision bore, so we're going to use a reamer. It is 504. So we're going to, again, same thing, drilling operation. New tool. Call it 19. Go ahead and select reamer, 0.504. I'm going to use the same feeds and speeds, 1,000 RPM, 25 inches a minute. And I'm going to select that hole. Okay guys, here's where we got to be careful. Since a reamer is not designed to cut, and we want to go past that hole, a reamer is not designed to plunge, I'm sorry. We want to go past that hole, so what I'd like to do in my heights tab is rather than choose an arbitrary number past the hole, I'm going to select that face right there, and I'm going to make sure I'm 50 thou above that face. Okay, so the only thing left to do is to chamfer this part. Again, since we have the chamfer in the model, we're going to choose a 2D contour. My chamfer tool is always tool number 5. So let's go ahead and select this. I'm going to bump this up to 10,000 RPM and 110 inches a minute, just to speed it up a little bit. As far as our chamfer tip offset, let's make it 80 thousandths of an inch. Okay, now let's chamfer the O-ring groove and the precision bore. 1, 2, and 3. 0.10 of an inch. It's fine. 0.005. While that's generating, let's go ahead and chamfer that edge. I'm going to select that as my geometry. 10 thou, 0.150, and 0.05 of an inch clearance. But we do have one over here that's got a problem, and it's a lead in and lead out problem. I just know that from experience, so let's just take away the lead in and the lead out. Alright guys, so that's as good as we're going to get because our chamfer mill is going to hit that side right there. So when we cut this, we're going to cut the jaws first. We're going to cut the two operations in the jaws first, and then we're going to come back after that's done and suppress that cut so that we can now cut around this part here. What you will notice is we didn't cut anything inside of here. We didn't cut the outside because that was all done, and we didn't rough these holes out either because that was all done in the previous operation if you watched the other video. So I'm going to simulate it real quick, let you guys look at it. So here we go. There it is. Now what you'll notice is it didn't simulate these holes being there because it doesn't know that we cut them on the previous operation. So guys, appreciate you following along. We'll get back to you soon.